channel. Today we will learn on topic forces, chapter 4, part 2. Okay, where we will learn the object is accelerated. Okay, so let us begin. Okay, so for questions number 7, this diagram shows that there are two objects, G and also H. So when we have two objects, we need to draw two through three body diagram. So for the first one, H, okay, we need to ask 5 questions because we have 5 forces. So we need to ask whether we have the weight, tension, frictional force, normal force, or F external. Okay, so for H, okay, H we have mg, we have the weight. Okay, besides that, this is a smooth surface, so we don't have friction, we don't have tension because there's no string. Okay, but we have normal, okay, because there is a contact surface. Okay, so just now this is weight and this is our normal force. So I draw here we have normal force, and we also have the reaction force between G and H. So if we refer to H, meaning that there's a reaction force acting on G to H. Okay, so we draw, there's a normal force or the reaction force on G to H. Okay, so this is the free body diagram for H. Okay, next one, we go to object G. So for object G, of course, we have weight, we have normal, okay, we don't have tension, we don't have friction because it's a smooth surface. Okay, we have our normal force, the reaction force that acting H on G, okay, and also we have F external. Okay, this is actually a push force. So we draw out from the origin, this is a normal force, this is weight for object G. Okay, this is the F external, the pushing force, and the last one is the reaction force H acting on G. Okay, so bear in mind that our RGH is actually equals to negative RHG. Okay, the magnitude for both are the same, okay, but they are opposite direction. So now let us write the equation for both. Okay, so for object H, we have X and also Y component. So we start with Fx equals to ma for H, where our H we only have RGH. So we write as RGH equals to M. Of course, this M is for H. Okay, it's for H. And then F equals to MA, right? So our M is equals to HA. This is our first equation. Okay, for Y exit, Y equals to MA as well. Okay, for H we have normal force and we have weight. Okay, so normal minus weight, because normal is acting upward, weight is acting downward. Okay, is equals to M, and again this M is for HA. Okay, for Y component, we know that this G and H is not moving up or down. Okay, it only moves to the right. So we know that A is equals to 0. Okay, so we know that our normal force will equals to weight for H. This is the second equation for H. Okay, next we go to G. Okay, G, because the motion is to the right, so we know that F external is greater than RHG. Okay, F external is same directions with our motion, so we write as Fx equals to ma. Okay, so F external minus RHG is equals to M. Of course, this M is for G. A. This is our third equation. And for Y component, because as I mentioned just now, y component, the object is not moving up or down. Okay, so meaning that our normal force will equal to weight for G. So this is our fourth equation. Okay, next one. Questions number 8. Again, we have two objects, I and also J, and the motion is to the right. Okay, so meaning that to the right is positive, to the left is negative. Okay, let us start with object I. We need to ask 5 questions: weight, tension, friction, normal, and also F extension. We have weight, we have normal force, we have tension because there is a string, we have frictional force because the question says rough surface, so the frictional force, but we don't have F external. Okay, so we transfer it to draw the free body diagram where we have tension, mg, the weight, frictional force because there is a rough surface, and frictional force is opposed the motion. Motion is to the right, frictional force will be to the left. And of course, the last one is normal force because there is a contact surface. Okay, so this is for object I. Object J. Okay, object J is, we also need to ask 5 questions. We have weight, we have tension. Okay, so tension for I, tension for J, actually they are referring to the same thing because they are same string. Okay, tali yang sama. So we will have tension yang sama. Okay, frictional force we have, and it's always opposed the motion. Normal force we also have, and also we have F external. Here there is a pulling force acting in front of J. So we draw out all the forces for J. F external, weight, here we have tension, we have also friction, and last one is the normal force. So this is J. Okay, so next let us write the equation. Okay, so I will split. Okay, for I here is x component, this is y component. Our E, the magnitude, the resultant Fx is equal to ma, and a is not 0 because the question said is accelerated here, is accelerated, meaning that a is not equal to 0. So our motion is to the right, meaning that the tension is greater than our friction. So we write tension minus friction equals to ma. This is our first equation for I. For y, the resultant Fy equals to ma. Again, as I mentioned, the object is not moving up or down, it's just static at y component. Okay, so this one is equals to 0. Therefore, our n minus weight equals to 0, or we can write as n equals to weight for I. Okay, next we go to object J. So x and y component as well. The resultant Fx equals to ma, and a is not equal to 0 for x component because the motion is moving to the right. So since the motion is moving to the right, meaning that F external is greater than tension plus friction. So F external minus tension plus friction equals to ma. Next, for y component, Fy equals to ma. Because the object is not moving up or down, so our resultant for y component is equals to 0, meaning that our normal force is equals to the weight for object J. Next, questions number 9. We have two objects, object L and also object M. So let us look at object L first. So before we start, usually we will ask 5 questions. So do we have the weight? Yes, we have weight. We have a normal force. We we have tension because there is a string. We also have the frictional force because this is a rough surface, but we don't have external force. Usually external force is given, or either is pulling or pushing force. So we transfer all the forces, start from the origin. Okay, start from the origin, we have tension, normal, weight, and also we have friction. And the motion, it is to the right. Okay, so this is the motion. Okay, next one, we goes to object M. Object M, this object, it is, because the motion here is to the right, meaning that M will move downward. So M will move downward. Okay, so our weight for M is downward as well. There's a tension, and we don't have normal force because here you see there's no touching contact between the object M with the wall. So there's no contact surface, no contact, no normal force. And also we don't have frictional force because we also don't have any contact with the wall, and we don't have F external. So we only have tension and also weight for object M. And the motion is acting downward. So let us construct an equation for object L and also M. So again, for object L, Fx equals to ma, and a is not 0 because the question says object is accelerated. So because of the motion is moving to the right, meaning that the tension minus friction. Okay, tension is greater. Tension minus friction equals to m for object L, A. Okay, y component is F, the resultant of Fy equals to ma. Because for object L, there is no motion acting upward or downward. So we know that for y component, it is equal to 0. Therefore, normal minus weight equals to 0, or we can write as normal equals to weight for object L. So this is our second equation. Next, we go to object M. Again, there's no x component because for M only y component. So x component we don't have. Okay, so this one we don't need to write x component. Okay, we don't need to write because there's no x component. So we straight away we go to y component. And this time your y component is not equal to 0 like object L. Object L motion is to the right. But for object M, the motion is downward. So A is not equal to 0 in this case. So we cannot put A equals to 0. Okay? So because A acceleration, the motion is acting downward, meaning that our weight is greater than tension. So we take weight minus tension equals to the mass for M, A. And bear in mind, these two T on object L and also T on object M are the same tension because they are same string. Okay, so for question number 9, there are 3 equations. Next one, diagram number 10. Here we have object P and also object Q. Okay, so let us look at object P first. Where P we have we have the weight for P. We don't have normal because there's no contact surface. We don't have friction. We also don't have F external. Okay, so we have tension. Okay, let's say I label T1. Okay, so I transfer it. We have weight for object P. We have tension, let's say T1. For Q also we only have weight for Q, and also we have tension T2. No friction, no normal, and also we don't have F external. Okay, and remember our T1 is equal to T2 because they are from the same string. Okay, so I transfer the forces acting on Q to draw the free body diagram. So this is our weight for Q and also tension for Q. Okay, If you don't want to write T1, T2, you can just write T because they are same T. Okay, so next let us construct the equation for object P. So this is P, this is for Q. And if you observe the free body diagram, for P and Q, there's only Y component. So we can only write one equation. Fy for P is equals to MA and it's not equals to 0. You see the motion here, the motion, the arrow is pointing upward. Of course, this one when it go upward, P will go downward. Okay, so the motion for P is moving downward. The motion for Q is moving upward. So P, the motion is downward, meaning that our weight for P is greater than tension. So weight minus T equals to MA. Okay, so this is first equation. Second equation is from Q. Okay, second equation is from Q. Because only Y component, so we only write Y component F equals to MA. And the motion is accelerate upward, meaning that the tension is greater. So I take tension minus weight for Q equals to MA. This is our second equation, meaning that we always refer to the motion. The force similar or same directions with the motion is positive. Opposite with the motion, we consider it as negative. Next one, diagram number 11. Diagram number 11 until 13 is the motion in a lift. So assumes that this is a lift and this V is V constant. Okay, it is moving but with constant velocity. So we know that when V constant, meaning the acceleration is equals to 0. Okay, so for this person, we need to ask 5 questions as well. Okay, we need to find out what are the forces acting on this person. So this person, there is a weight, okay, and there is a normal force. We don't have friction, we don't have tension, and also we don't have external. So therefore, we only have 2 forces acting. Okay, and the motion is moving upward, right? Okay, with V constant. Okay, so our equation only Fy equals to MA and MA is equals to 0 because of V constant. So therefore, we must follow the motion where when it is moving upward, meaning that our normal force is greater than weight. So we write as normal minus weight equals to 0. So therefore, our normal force is actually equals to the weight. Okay, next we go to 12, diagram number 12. Diagram number 12, also this is a person but there is an acceleration that is moving upward. Okay, so again, this person, there is a weight. We also have normal force. Okay, so we have weight and also normal force. And it is accelerate upward. So the equation that we will get only Y component where the resultant Fy equals to MA. Now A is not 0 anymore because it's accelerated. So we write as normal minus weight equals to MA. And the last one, diagram number 13. This person is, the lift is accelerated downward. Okay, the motion is acting downward. So we also have the same force, normal, and also we have weight, but now the motion is acting downward. Of course, when it is acting downward, we can write it as, because it's acting downward, meaning that the weight is greater, so we take weight minus normal equals to MA, and A is not equals to 0, it's accelerated. Okay, so that's all for today. Hope you enjoy my video. Okay, remember to subscribe my channel and click likes. Okay, see you on next video for the exercise. Bye and have a nice day.